friends, last we discussed about the Young's double slit experiment and we obtained the equation of path difference at a point at which the waves emanating from the S1 and S2 are superposed, and at this point either the constructive or the destructive interference is formed. We obtain the general equation of the path difference is x small d upon capital D. If this path difference is equal to a condition of constructive interference in lambda, at that time, at this point, the constructive interference takes place and intensity at that point is maximum. And if this equation of the path difference x small d upon capital D is equal to the path difference of destructive interference, so in that case, at given point or that point, the constructive interference takes place and intensity of the fringes is minimum, that means the zero. Now, today we are going to discuss about that. In Young's double slit experiment, we already discussed about the interference pattern. One is the bright, dark, bright, dark. This type of the continuous lines are obtained, where the fringes are obtained. What should be the distance between two consecutive bright fringes or two consecutive dark fringes? This question is asked this year, that means in 2020 for 2 marks. So that is the most important. Earlier, we also discussed that to obtain the condition for constructive and destructive interference in terms of path difference and phase difference, that is also important for 2 marks question. Clear this? Okay. Now, today we are going to discuss about to obtain the equation of the distance between two consecutive bright and two consecutive dark fringes. And we prove that the distance between two consecutive either bright or the dark fringes are same and is equal to the lambda capital D upon small d. So first we obtain the distance between two consecutive bright fringes. Bright fringes is obtained due to the constructive interference. Therefore, we start from this for constructive interference. For nth order bright fringes, already we know that the distance xn is equal to n lambda d upon capital D. N lambda capital D upon small d. Here the xn is the distance of point from O on the screen at which the nth order bright fringes is obtained. That is for nth order bright fringe. And for n plus 1 order bright fringes, so this equation is x n plus 1 is equal to here n plus 1 into lambda capital D upon small d. That is our equation number 2. That is our equation number 1. That is our equation number 2. Actually here, what it represents for that purpose here on the screen, that is our screen. That is the center point of the screen. This point, the P, here nth order bright fringes is obtained. The distance is xn from O. And now, next consecutive bright fringes is P here n plus 1 order bad fringes is obtained. The distance of this point is from O is xn plus 1. Is xn plus 1. Let's find out the distance between these 2 points. So there is the distance between the 2 consecutive bad fringes. These 2 points are located at xn and xn plus 1 distance from the O on the square. Therefore, the distance between two consecutive bad fringes is, that is the xn plus 1 minus xn is equal to n plus 1 lambda capital T upon small d minus n lambda capital T upon small d. Therefore, lambda capital T upon small d is common. Inside the bracket, n plus 1 minus n. That is cancelled. Therefore, lambda d upon d. That is the separation between two consecutive bad fringes. Suppose that is the beta. That is the beta. That is the equation number 3. So thus we obtain the distance between the two consecutive bad fringes. Okay. Now, for destructive interference, we obtain. First, we write down the direct equation for the position of nth order direct fringes. Therefore, for nth order direct fringe, that is our xn dash. Xn dash is equal to, now here, n plus 1 by 2 into lambda capital T upon small d. Or in other words, this equation you will show it as 2n plus 1 into lambda d upon 2d. Lambda d upon 2d. That is the equation number 4. Here, xn dash, there is the distance from O of a point at which nth order direct fringes is obtained. Is equal to, what is the xn dash? Is the distance of point at which nth order direct fringe is obtained. And for n plus 1 direct fringe. So directly we can write xn dash plus 1, or the xn plus 1 dash is equal to, instead of the n, here we substitute the n plus 1. 2 into bracket n plus 1 plus 1 lambda d upon 2d. We simplify that. Therefore, 2n plus 2 plus 1 lambda capital T upon 2d. Therefore, there is 2n plus 3 lambda capital T upon small d. There is the xn plus 1 dash. Equation number 5. Therefore, the distance between two consecutive direct fringes is xn plus 1 dash minus xn dash. is equal to 2n plus 3 lambda d upon d minus 2n plus 1 lambda d upon 2d. Here lambda d upon 2d is common. Here 2n plus 3 minus 2n minus 1. 2n cancel, therefore 2 lambda d upon 2d. 2 cancel, therefore lambda d upon small d. That is xn plus 1 dash minus xn dash. There is a equation number 6. There is a beta. There is equation number 6. So that is the distance between two consecutive direct fringes. Thus, distance between two consecutive bright or dark fringes is equal. That is beta. And beta is equal to lambda d upon d. So that is very easy, only the mathematical steps of the answer of this question. So that is most important, and frequently this question is asked. Again, what is our aim? Our aim is to obtain the distance between the two consecutive band or the two consecutive direct fringes. For that purpose, directly we accept that already we discussed in Young's double slit experiment. We obtain from the condition of a constructive interference, we obtain the equation of the distance of nth order band fringes xn is equal to n lambda d upon d. Therefore, first we are down for constructive interference. For nth order band fringes, xn is equal to n lambda d upon d. xn is the distance of point P from O on the scale, where the nth order band fringes is formed. That is equation 1. And from this equation, and for n plus 1th order band fringe, xn plus 1 is equal to, instead of the n, we place the n plus 1. So n plus 1 lambda capital D upon small d, equation 2. To take the distance between the two consecutive band fringes, we take the subtraction of equation 2 and 1. Therefore, the distance between two consecutive band fringes is xn plus 1 minus xn is equal to n plus 1 lambda d upon d minus n lambda d upon d. Lambda capital D upon small d common, therefore n plus 1 minus n cancel, therefore there is the lambda d upon d. Suppose there is the beta. Now, for destructive interference, that means for the direct fringes, for nth order direct fringes, directly we accept xn dash is equal to n plus 1 by 2 into lambda capital D upon small d, or 2n plus 1 into lambda d upon capital D, equation 4. What is here xn dash? Is the distance of a point at which nth order direct fringe is obtained. Now, and for n plus 1 direct fringes, here we replace the n by n plus 1, therefore xn plus 1 dash is equal to 2. Instead of the n plus 1 into lambda d upon 2d. We open the bracket, so 2n plus 2 plus 1 lambda d upon 2d. Therefore 2n plus 3 into lambda d upon capital small d, equation 5. Therefore, the distance between two consecutive direct fringes is xn plus 1 dash minus xn dash is equal to 2n plus 3 into lambda d upon 2d minus 2n plus 1 lambda d upon 2d. Thus, we again obtain the same distance for two consecutive direct fringes is lambda capital D upon small d. So, from equation 3 and 6, both are same. Therefore, the distance between two consecutive bright or the dark fringes is equal to. Now here, this figure is not important, but for our understanding, why we take the n and n plus 1 order, either the back or the diagonal fringes. For that purpose I do it, that is not important. Just we derive the equation of distance between the two bad and two diagonal fringes. After that, in Young's double slit experiment, we obtain the interference pattern. What should be the shape of this interference pattern? Right? So always the straight line, all the fringes are straight. So for that purpose, here we are discussing about that. Already we know that for the bad fringes, the path difference is equal to integer into wavelength, because the condition for the constructive interference is equal to n lambda. For that purpose, if path difference is equal to integer into wavelength, at that point, what are the fringes is obtained? So this fringes is there. The fringes will be there. And if path difference is equal to odd integer into wavelength, fringes will be dark. Fringes will be dark. Now, we know that the interference pattern depends on the path difference at a point on the screen. Therefore, if the path difference that means according to a figure S2 P minus S1P is remain constant. Therefore, the trajectory at point P on the screen is hyperbola. If the path difference is S2P minus S1P is equal to delta is equal to constant. The trajectory at point P on the screen is hyperbola. And we know that in Young's double slit experiment, first is the slit S, then slit S1, S2, and at some distance, that means at capital D distance, the screen is given. That is the slit S. After that, the slit S1, S2 here, S1 and S2, and at the some distance, there is the screen GGS. If the distance between the slit and screen is small, at that time, the straight line is obtained on the screen as an interference pattern due to the superposition of the cylindrical and if the distance between slits and screen is very large, the straight line are obtained as a fringes as shown in figure A and B, as shown in figure A and B. So figure A represents the hyperbola like this way. As the distance from the center point is going to increase, the fringes are going to curve. So there is a figure 8. Right? Here the distance between the slit and screen is not very large. There is quite less. And for figure B, all the fringes are plain line. In which case, if the slit and screen are at large distance, that is figure B. There is only for knowledge which type of the interference pattern we obtain in Young's double slit experiment. Not each and every time here the parallel fringes are obtained. Sometimes this type of the hyperbolic, the fringes are also obtained as an interference pattern in Young's double slit experiment. That is depends on what are the distance of the slit from the screen. There is our screen. Here is, so there is the answer of a question. There is the shape of the interference pattern in Young's double slit experiment. Okay, now after we discuss our discussion about what is the shape of the interference pattern. Now we are going to discuss about that. What is the intensity of the each and every fringes obtained in interference pattern? That means we are going to discuss about the intensity distribution curve for interference of Young's double slit experiment. For that purpose, first we discuss about what is the arrangement of Young's double slit experiment. As shown in figure, Young, that is the Thomas Young, name is, who performed this experiment, take a slit S on screen A and the slit S1 and S2 having the distance S2, S1 and S2 are equal. That means both are kept parallel. Screen A and screen B are kept parallel. On screen A, one slit S and on screen B, two slit S1 and S2. So both screen A and B are parallel. And screen C is placed at the far from the B. That is also parallel to the screen A, B and C. All three are parallel to each other. So at that time, the plane straight line fringes are obtained due to the superpositioning of the cylindrical wave emanating from the slit S1 and S2. So this is the arrangement of Young's double slit experiment. So we write down here like this. As shown in figure. As shown in figure. Young take a slit as on screen A. The slit S1 and S2 slits S1 and S2 having SS1 is equal to SS2 on screen B. On screen, the screen A and B are parallel to each other. Parallel to each other. The screen C is placed at far from B. The plane straight line, the simply straight line are produced due to superpositioning superposing the cylindrical wavefronts emanating from S1 and S2. So this way the interference pattern is formed in Young's double slit experiment. Now the distribution curve of intensity distribution curve of interference pattern of Young's double slit experiment is shown in the figure. The intensity distribution curve for interference of Young's experiment is shown in figure. It's shown in figure. It's shown in. So here we do the distribution curve. Young's double slit experiment is like this way. So there is the central band fringes. So there is the central band fringes. After that, the first order band fringes. There is the first order band fringes on either side of the central band fringes. Now after that, the second order band fringes is obtained. Also in this side here. So there is the 0th order, there is the 1, n is equal to 1, or the lambda is equal to 1, n is equal to minus 1, here n is equal to 2. Here also n is equal to minus 2. So here there is the intensity. There is the maximum intensity I max. So from the graph, the width of each band fringes and intensity will be same. From graph, the each fringes of same width and same intensity. Each fringes of same width and same intensity. Second point is that the point at which the dark fringes produce, right? The intensity at that point is minimum, that means the 0. The point at which dark fringes obtained. Dark fringes obtained. The intensity at that point is 0. That point is 0. And third is the distance between two consecutive band or the two consecutive dark fringes are same. The distance between two consecutive bright or dark fringes will be same. Here each bright fringes. So So these 3 points we can discuss from the graph. Now listen, for each and every band fringes of the same width are same, and intensity are also same. Now this point at which the destructive interference takes place, that means the fringes are dark, the intensity is completely zero, and the distance between the 2 consecutive band fringes, that means this distance is remain same, or distance between the 2 consecutive dark fringes also same. There is okay. So here the interference is completed. Now in next lecture we discuss about the numerical depends on the interference.